Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's have a discussion on this past year question. Question of the year 2012, majoring paper, variance 43. So for this question is to check your understanding on the chapter 3, which is about the Newton's law. Have a look at the question here. A block A of mass 3 kg is attached to the S1. Another block of the mass 2 kg is attached to another end of S1 and also to the S2. So this system is hang in equilibrium. Everything is shown in the diagram. And for the part 1, you are asked to find the tension in the S1 and the tension in the S2. So let's have a look at S1. So for the tension in the S1, we will just need to look at the particle A. For the particle A here is in equilibrium. When it's in equilibrium, which means the force going upwards and downwards are the same. So for the particle A, the force that is going downwards is just 30 Newton, and therefore the upward force, which is the S1, should be equals to 30 because it's in equilibrium. The upward force and the downward force should be the same. Now let's have a look at the particle B here. So particle B, the downward force is actually from here and here, because these two particles' weight is actually going downwards. So the downward force is 20 Newton plus 30 Newton. And the upward force here is just S2. Therefore, the S2 should be equals to 20 plus 30, which is equals to 50 Newton. That's how we find out the S1 and S2. For the second part, it's mentioned that the string S2 breaks and the particles fall. The air resistance on the A is 1.6 Newton and the air resistance on the particle B is 4 Newton. So now it's mentioned that there's no more S2 here because it breaks. Then it's just left with the particle A and B. So let's say I sketch the diagram again. This is a B connected to the A. And for the part 2, you are asked to find the acceleration of the particles and the tension in S1. So both the particles are connected and therefore they will travel with the same acceleration and the same tension. So let's have a look at the particle A. What we need to do is just form an equation for F equals to ma. So have a look at the particle A. The downward force is 30 Newton and the upward force is the tension here and also the air resistance, which is like the friction, 1.6 Newton. So to form the equation now, it should be downward force minus the upward force as the particle A is moving downwards. So it should be 30 minus 1.6 minus T equals to 3A. That's the equation for the particle A. And let's have a look at the particle B. Same thing, what we need to do now is just to form the equation of F equals to ma for the particle B. So for the particle B now, it's being pulled downwards by the tension and also by the weight itself, which is 20 Newton. And the air resistance on the particle B, which is acting upwards, is 4 Newton. And therefore, the equation for the particle B, it should be T plus 20 minus 4 equals to 2A. So from here, you should be able to solve simultaneously to get the value of A and the T. For the A value should be equals to 8.88 as for the t is equals to 1.76. That's how we solve for this question.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.